Hi, good afternoon. Happy Monday. How
Good
are you?
afternoon, Professor.
Okay, I'm good. How are you? I see only three people. What's happening? Oh yeah, Zaniev is joining. All right, so I guess people are. Uh, I guess I don't know. It was such a great day today, so I guess they are still enjoying outside. Let me also. Okay, on my other machine, I have to also. Hey, good afternoon, Zaniev. Happy Monday. Rustam has just joined. Rustam is all righty. Good afternoon, everyone. Um, okay, let me share my screen. What's happening? Share application. Okay, entire screen. Okay, so you should be able to see my screen now. That's my screen, and Zaniab said hello to everyone. Alrighty, so I have six people, and give me a second. I also need to join as student. What is this? Oh no, no, no. Now, some of you, okay, I need to first, okay, join as student or preview user. Okay, yeah, I'm getting in there, I guess. Audio is working. Video is working. Okay. Everything is gone. All right. Okay. And I need to. All right. So we've been talking about the factoring, and factoring is actually, discounting method, discounting of promissory notes, right? Using simple interest rate, right? Simple interest rate. So it's called the simple in. It's also called simple interest or bank interest, right? Simple interest or bank interest, because bank is usually the institution that is discounting uh, this promissory notes, right? So the first three videos we watched last week. So we're gonna watch, the remaining videos, uh, and uh, we were, some of the examples in the last two videos included um, how to figure out what is the principal, what is the rate, what is the time, based on the uh, uh, based on the formula, uh, which is interest rate is P times R times T. That's the way to calculate simple interest. There's no compounding involved, right? So that video is still available, right? You can still watch those videos on my YouTube channel. I gave you my YouTube channel link before. It's probably no longer visible on Blackboard, but it is always there on my YouTube channel. If you want to review it, you can definitely go there. And so today, then, we're going to look into a couple of other examples of how interest-bearing notes can be discounted. And previous example was about the non-interest-bearing notes. But this time, interest-bearing notes, and basically, the etymology of the term factoring. Where did it come from? I mean, this factoring sounds like something from the algebra, but it has nothing to do with the algebraic origin. It has a different origin. So here, let's take a listen. Okay.
Now, in our last class, we took a look at the example of discounting non-interest paying promissory note, right? So now, in this segment of the video, we are now going into we're going to discuss discounting interest-bearing notes or interest-paying notes. Now, here's the I've been telling you all along, simple discount is also called bank discount, right? And it is a procedure or process to negotiate the sale of the promissory notes, and you normally you negotiate it with the bank, but actually it's not the bank. I mean, bank could be a party that could be part of this. Bank could buy the promissory notes, but more frequently it is a financial company called factors, right? Factors, financial companies called factors. And usually these companies are named, something like ABC Finance, right? Now, so they generally buy these promissory notes, and not just the promissory notes. And the promissory notes are promissory notes are a part of accounts receivable. But there's a slight difference between. But remember, promissory notes and accounts receivable are usually listed as separate line items in the balance sheet. In the current assets section, they are listed as separate line items. And if promissory notes are part of the accounts receivable, I would feel more comfortable to put it as a sub-line item of accounts receivable. But they generally write it as separate line items. Why? I'm gonna get to that later. But there's a reason. And I also told you the promissory notes are also called commercial paper. Now, if you took Finance 100 with me and in the Principles of Finance with me, you might remember that the name commercial paper is reserved for a certain category of bonds. In other words, a short-term corporate bond. It's called commercial paper. Then so they are the same thing? Yeah, they are basically the same thing, but the context would be slightly different, right? When you call them promissory notes and when you call them commercial papers, it's in slightly different context. But I'm going to get to that later. But first of all, so factors, right? Factors like ABC Financial. These are the financial companies that specialize in buying these promissory notes and discounting it to the company that is selling these promissory, because the company who sells these promissory notes are, as I said, in a cash flow problem. They have run into a cash flow shortage problem. So they have to. It's better to sell it at discount rather than holding on to it and face potential default, right? So I'm going to come back to this aspect of accounts receivable and factors later. But let's take a look at the. No, since let me finish this. I don't know if I can do this in. Okay, maybe it will take too much time. So, but let me try. So where did the word factor come from then? Where did the word factor come from? Factor is, you might think, oh, it's a factor of something, like you multiply this by the factor of 10, or so factor in English language, of course, factor means we know what it means, but actually, so you might think, oh, because they are basically discounting it by factor of 0.10, 0.1. Splitting it by 0.1 and by factor of 0.1 and 0.9, that's probably why. No, it has nothing to do with that. Okay? Interestingly, the word factor actually comes from, let me delete this, it actually comes from the French word facture, okay? And facture means, la facture, okay, la facture, la facture. And what does that mean? That means invoice. In French, that's invoice. And it's not only in French. There are several European languages that share the same etymology. In Italian, it is like la fattore, I think, la fattore. I'm not going to write the article again because in French and Italian, it's the same feminine, right? La fattore. And Spanish, it would be like factora or something, similar. It's not only in Romance languages. You might think, Italian, French, Italian, Spanish, they would probably have the same. Even in Czechoslovakian, it's actually factura. And Czech is a complete different language group. It's Slavic language, right? Not even Germanic, it's Slavic. And in Czech, it's factura. How do I know? I've been there. A couple of years ago, I went to Prague, Czech Republic, and then I stayed there for a few weeks and rented a car, drove down to Vienna, Austria, and then stayed there, a couple of days, more than almost a week, and then I drove down to Budapest, Hungary, and when I came back, I came back to Prague, and I had to return the car, right? When I returned the car, of course, when you rent a car, you use, credit card, so it's prepaid. I mean, when so you have already a credit card receipt, so it's already prepaid, so you don't need any invoice. But it's just it's just business protocol. When I returned the car, they gave me. What do you think they gave me? Of course, they will give you that the car is returned, with every conditions satisfied, right? Car has no damage, no dent, free of any defect, with full gas tank and et cetera, right? And then they, as a final document, that the car was returned, clean and free of any damage, right? Of course, that document, there could be a separate document, stating that, but what I received was saying factura. But then, what's the point? I mean, at that point, I don't need an invoice anymore because I already paid when I rented the car. With my credit card, I already paid. But this is a protocol, right? Just a business operating protocol. Now, it's not only in Czech, in Dutch. Dutch is Germanic language, and even in, that doesn't mean in German it's something similar. German is different. Russian is different. But then in Dutch, it is written, it's factuur, and it is written in more intimidating way. Now, reading this, just trying to read this is already very intimidating. So, what does this mean? These words all mean, and then when this came to English language, right, it got anglicized. and then became factor, right? So basically, what does that mean? Factoring is originally a business of buying invoices at discount. Invoices at discount. So what does invoice have to do with it? I mean, wasn't it the promissory note that they were discounting? Actually, I told you, promissory notes are a kind of, accounts receivable. And what's an accounts receivable? Exactly, that's the payment, right? Money you haven't received yet for selling something. You've sold something, you've sold merchandise, but you haven't received payment yet. You haven't collected yet. But that's the concept, that's the idea. So we can easily understand, I mean, because from the semantics of the word, anybody can understand what accounts receivable implies, right? But that's just a concept. What is the proof? What proves that you have claim to money that they owe you? Huh? In other words, promissory notes are not only a concept, but also it is a physical proof by itself. Isn't that right? Promissory note itself is already a physical proof that they owe you money, right? When you have that promissory note issued by someone. But then what is the physical proof of accounts receivable? It's the invoice. Invoice is the physical proof. So invoices generally, have, also like maturity, right? It says, please pay this. Of course, they generally give, like it's basically like a supplier's credit, right? Supplier's credit. In other words, we are selling this merchandise to you, but we are giving you 60 days to pay. Or, to facilitate prompt payment, they give generally something like discount for early payment. Or, but anyway, the physical proof of accounts receivable is invoice. And then, remember, what does, factor mean? Invoice. So factoring, I told you, what is factoring? Factoring was originally a business of buying invoice at discount, hence called, this is simple discount or bank discount is called factoring. If the bank is doing this, it's called bank discount. But I've been telling you, small, mostly, third party, small financial companies are specializing in this, and they are called, factors, right? So now, as an example of discounting, so in this example, we are interest-paying notes. Now we have, oops, so sorry. Now we have, this should be called maturity value, not future value, right? That's fine. I mean, future value, maturity value, that's the same thing. But let's think about it. Principal, $300,000 principal at interest rate of 10% with 180 days to maturity. So this is, I use normally, lowercase t, right? But why uppercase t? Uppercase t means, terminal time. That's the from day zero, time zero, all the way to the time, the last day, the ultimate, terminal time. So uppercase t means represents terminal time. This is the entire time left on this bond, or on this note. So if we use, 180 days is half a year, right? So, but I discounted it. I used, 365, right? So this is, exact interest year, right? So I can annotate review. So I will do it later. So then what's the maturity value? Because this is, with interest, all you need to do is, you already know this, principal times 1 plus R times P, right? And then that's the maturity value. But, on day 60, now, how do I, the verbiage, it's missing verbiage, but, from the data, I can tell this is the discount period, right? How do I know? The time left, to maturity is 120. What does that mean? For the first 60 days, this company was holding on to this promissory note. Again, for the first 60 days, they thought it's obvious, they didn't have any cash flow shortage problems. So they were hoping to hold it for 180 days and collect, this maturity value. That's, almost, $15,000 more. But on day 61, they can't do it anymore. They ran into a cash flow shortage, so they ran to the bank or a factor, and then they factored it, right? They factored it. They factored this promissory note, and the discount rate the factor used was 12%. Discount rate they used was 12%. So then 120 days is converting into years, 0.33. So what's the proceeds, right? Once again, D proceeds, the discounted amount. Then all you need to do is you will be, because this is the maturity value, you will be discounting, but the discount period is 120 days. And so 1 minus, right? The discount rate is 12% times T, right? And then what do you get? This is what you receive. This is the proceeds. And then what's the bank discount? Bank discount will be the difference between, you can calculate it separately, right? Like maturity value times D times T, but we know what we got this already, so it's the difference between the two, clearly. And bank takes this for their service, right? They have to get something from this because they are taking over this promissory note, and unless the issuer of the promissory note is, very high quality, right? The risk, there's a lot of risk, right? So they will have to cover there. And then, good. What is this? I'm going to have to come back to this later. This is called, effective interest rate. Effective interest rate. Okay, effective interest rate. But I will have to come back to that later. Next example. So just $100. That's too. Let's make it $1,000. $10,000 at least. Okay. So once again, this doesn't have to be only promissory note. This can be also an invoice, but in most cases, invoices don't have interest. So in most cases, invoices would be like discounting invoices would be like non-interest discounting non-interest promissory note. Okay, but anyway, so the maturity, the entire duration length of this note is 90 days from day 1 to the terminal time, right? Of course, this time they used ordinary interest here, right? You don't have to do that again. You can just copy that, right? And discount rate is 18%, and 40 days with 40 days remaining. So what does that mean? For the first 50 days, they were holding on to it, right? And then they ran into cash flow problem, cash flow shortage. So they ran to the bank or factor and discounted it. And 40 days is, of course, using ordinary interest here. That's what it is. And you don't have to do all of this again. So you will just drag it down, and this is the proceeds, and this is the bank discount. Now, last but not least, I always say, what's important is the also the housekeeping, right? I don't want to leave it like this, so I will make right the bottom border, and this doesn't look good, so I'm gonna no border, but then this doesn't look good, so I'm gonna put bottom border, thick bottom border. Okay, now this side border, that I don't like that, but I'm gonna take care of that later because we still have a couple of things. Now here, we have now we need to understand what effective interest rate is. But actually, the exercise we'll be doing the exercise on the effective interest rate in the next video. But you might think, so back to this our first example, zero non-interest paying promissory note. So in that case, suppose ignore 60 days. That was one. Ignore 60 days. Suppose if principal was 10K and you factored it and you got 9K. So that means the bank discount was 1K, 1,000, right? Then what would you say? Does that mean the interest rate in this case, the bank took, does that mean that means discount rate was 10%, right? Isn't that right? Discount rate was 10%. But then this 1,000 is like the interest that the bank takes, right? But then is it 10? So was the interest rate 10% then? I mean, for the bank, bank took the interest upfront, right? I mean, they are paying you 9,000 out of 10,000. So it's like giving you a $10,000 loan, but they took the interest of 1,000 upfront and only gave you 9,000, right? And then if you, it's like a pawnbroker. You took a $10,000 Rolex watch to a pawnbroker, and they gave you only 9,000. If you want the $10,000 watch again, they took 1,000 for their fee or interest. So they're telling you, you want back, bring us back 10,000. You will get. So I don't know if this is a good analogy, but I normally call this type 2 loan. But think about it. So they took $1,000 interest out of 10,000. So is the interest rate, and you is the interest rate 10%? Actually, 10% is discount rate, isn't that right? But from your perspective, right? From your perspective, you paid $1,000 interest for borrowing $9,000, isn't that right? For borrowing $9,000. So what does this mean? For let's say 1 year, for 1 year. So in terms of interest rate, right? You paid 1K to borrow 9K for 1 year. You don't have to write 1 year here, but you remember R is right from. Where did I write it? I think I erased it. You remember the this formula, right? If you want to find R, it's interest over P times T. So if you do that, this is the interest you paid, and this is the for using 9,000, for borrowing 9,000 for 1 year. You don't have to write 1, for 1 year. So if you do this, then is this 10%? No, it actually comes to something like 11.11%, 11.11. In other words, effectively, think about it. If you paid $1,000 to borrow 9,000 for 1 year, you paid effectively 11.11%, not 10% interest, right? It's like receiving. You wanted to borrow 10,000, but right, you paid. They gave you 10,000, but they took 1,000 upfront as interest, right? So it is 11.11, right? So this is called effective interest rate, right? So we're going to talk about the effective interest rate in the next video. Okay, all right. I'll see you guys in the next video. Stop recording.
All right. So any questions so far? Any questions? Any questions? Well, I'll take it as no. And so let's watch the video number 5. Number 5. Where is? Okay. The last video on factoring, right?
Simple discount. So our question is now, what is the effective interest rate? And in our last lecture, I said briefly, I made an analogy to a pawnbroker case, but that is, it could be like I mean, if we use some analogous situations from like TV, it could be like a mafia type of loan, right? Because if you get, in the movies like, Godfather, if you get a loan, if you ask for money, for a loan, from a like a mafia, um, $10,000 loan, and they give they will give you they will lend you money if you ask for some loan, right? They will lend you money, but for $10,000, they will just give you 9,000, right? And you have to pay back. So that means they took already 10,000 as interest up front, right? So that's usually the nature of money lending business in the organized crime depicted in the TV shows. And then you pay, so you effectively pay back $10,000, right? Because you back only 9,000, but you already paid, 9,000. You already paid 1,000 as interest in advance, right? Upfront, the minute you get the loan, right? And then, of course, I'm not saying this is the only way it works. I know how loan sharks operate, but this is a typical way. So in that case, actually, if you think about it, effectively you are not paying 10% interest. That's 10% discount, but you are paying more than 10%, right? 11. And I showed you an example, a very simple example using the non-interest paying loan, non-interest paying note, right? And in case of non-interest paying note, actually you have already paid back the loan, isn't that right? Because the $10,000 note is already the minute you sold it to them, they got 10,000 already, but you're getting 9,000. So it's like exactly that mafia loan. And I personally call that type 2 loan. Type 2. Type 1 is like simple interest or even compound interest. You borrow 10,000 and you pay back a year later 11,000. That's type 1, and that's a normal case. So then our next question is, how do you calculate that? How do you calculate effective interest rate? It's always, right? Effective interest rate is always, and I made a, effective interest rate is always B over MV times, right? Because, okay, effective interest rate is always, and if a symbol for effective interest rate is R star, okay, whatever you actually, whatever the bank took and whatever you actually got, and whatever you actually got is the proceeds, right? And then times T. Okay, I know, please bear with me. This is not my handwriting. My handwriting doesn't look any better than this, but it looks better than this, of course. I'm drawing, right, with the mouse, so everything is really difficult. R star, and of course, this is D times T. So it's exactly like, see, when you find it in simple interest case and finding interest, here, I did a stupid thing here. That's not, that's P times T, right? Yeah, I did a silly thing there. It's not, you're solving for R, so solving for this, so you cannot have R there again. So it's actually P. Okay. So using that formula, right? Using that formula, yeah, let's find the effective interest rate, which is B over, you must not forget this parenthesis, right? Hit enter. Oh, enter, and then, okay, you can drag it down. Now, this is the rate, and as you can see, the effective interest rate is greater than the discount rate. Right? It has to be, right? Just like the example, simple example I gave you before, 10K non-interest paying note, and they took 1K as the bank discount, and the process is 9K. Then of course you're paying 1K interest for 9K, so that's like 11.11, which is definitely greater than the discount rate of 10%, right? And this is also the reason I've been telling you. Suppose I've been telling you the importance. I've been preaching the importance of using 2 to 3 decimal places by default. Why? If you leave it, when I formatted these cells, I formatted all the cells to use 2 decimal places at least, right? So that means Excel's default is not 2 decimal places. Excel's default is just integer. Everything is, for example, it is the integer. You will. So suppose, you leave it as it is, right? If you leave it as it is, because Excel's default is completely rounded to integer, then there will be, what do you see? If you leave it like that, then there is no difference between discount rate and effective interest rate, right? Just looking at the surface of this, and I've been telling you how when you guys are young, this thing comes, this thoroughness and meticulousness comes with age. Actually, the meticulousness and thoroughness comes with age. When you're young, around 20s, generally you don't look at deep. You can't. You don't have that capability. You don't have that. Unless you're trained. You have to be trained only, right? Only if you're trained, then you analyze and you think critically. But otherwise, people are generally, looking at only shallow, superficial things. And I've seen a lot of students, they submit the problem is already asking for effective interest rate, but they are mindless. They don't, although they are, doing the effective interest rate, they just, in the homework, they just submit it like this. And that means they are not doing they are not using their judgment, right? You have to be critical or judgmental in matters like this, right? If you watch movies, they're always, they're always saying, oh, don't be so judgmental. You don't be judgmental about people, but don't be. You should be judgmental about data. You should be judgmental about facts, because that's critical thinking. That's part of critical thinking, right? Did I judge yourself? Be judgmental about yourself as well. Did I do it in a smart way? Did I act smart, or not just act, but do I do things in a smart way? Right? If you leave it like this, and and suppose you're presenting it and to the audience, presenting it to your clients, you should be judgmental about yourself and about your work, right? This simply tells you, if you leave it like this, this simply tells you you don't care. You don't care anything. You don't care about your work, right? So this is why it's important, right, to use 2 decimal places, at least 2 to 3 decimal places. I mean, as many digits it requires to make a difference, right? Okay. So if you don't do that, you're just doing it mindlessly, right? And in a, for example, in a professional situation, that only works to your detriment, because nobody wants to give you a job, right? If you are, mindless, right? If you're doing things in a mindless way or not in a smart way, you lose that, job, because everything is competition, right? There will be other bidders who want that job, or who want other bidders that want that project, bidding for that project. Now, so also a small detail, but last but not the least, once again, what did I say? So if you present it to your clients like this, and what is still missing? Housekeeping, right? That also tells something about you, right? If your housekeeping is sloppy, right? So 409. right borderline, so I'll have to highlight the whole thing and put a big outside border. Now, so everything is now impeccable. Okay, so now let's go to the next. So this is something you can do already very easily, right? So bank discount, and now they were, time was given in weeks. So what do you see here? You will divide it by 52. This is, you don't do this, but normally this is hard coding. I would rather put, I'm sorry, weeks in year, weeks in years, or things like that somewhere else, another separate data table. But anyway, that's 13 weeks, half a year, right? Now, so bond discount is the maturity value P times D times T. Okay, and then we know we can easily do that later. In this case, it's the same problem, but this time is D. D is proceeds P times 1 minus discount rate times, right? So this is like, what is the question? The question is, if you have a $10,000 note, right, and if you maturing in 13 weeks, right, if you factor it today, right, what's the proceed and what's the bank discount? And then we know it's the same problem, so this should be the same thing as this, and this should be the same thing as this. But again, we'll just, we know then the bank discount is the difference between the two. Bank discount is the difference between the two. All right, and effective interest rate, I'll just do one because they must have the same effective interest rate, right? B over E times T, right? There we go. Okay, so that's the difference, right? Discount effective interest rate is always greater than the discount rate. I'll just point to that because they're the same thing. Now, I will skip this because we don't have time. But here, now let's go to the last example. So it's actually two different examples, right? Two different problems. And this table belongs to this problem. I had to put this table there because there's an empty space. And if I put it here, then it's going to unnecessarily, restrict the, I mean, we have, a limited viewing area on the screen. Anyway, this one, this one is, this table is also related to both. Now, looks like, $55,000 promissory note with, 7.5% interest rate. But then, where did the time come from? Look at this. This one, what is this? Unlike other problems, now the time is given in calendar date. So T0, of course, T0 is the day one, right? The original date of the issue, right? The promissory original date of the issue of the promissory note, issuing of the promissory note. Uppercase T is always the terminal time. So this is the terminal time, right? This is the maturity, right? T1, this is the date when you discount it. This is the date when you discount it, right? So actually, this is I should delete this. And I should delete this too. Okay, and then so in the first problem, this is so what is the interest? What is the future value? The future value is simple, right? We know it is P times 1 plus R times T. Okay, and there you go. Okay? That's the future value. And the interest is the difference between the two, right? Which is not a big deal. There you go. and you can drag it down. I won't do that at this time. I'll do that. Okay? But what's important is not the how you find time, but think about it. When the time is given as calendar date, all you need to do is subtract, right, T0 from uppercase T, right, the terminal time, and then divide it by 360 or 365. In this case, I divided by 365. Again, to give flexibility, I will have. Okay, let's do this. It's really. Let's put it. So let me copy that here, and then. Okay, let's change this to 365 and 360. Now then think about it. So this is exact interest here, because instead of I'll point to that. So second problem uses ordinary interest here, right? First problem, exact interest here. So it's not a difficult thing. How many days? How many days is the maturity? It can simply be calculated by subtracting April 8th from September 15th. And some people actually look at the calendar and how many days are in April, how many days are in May. Now, 30 days, 31 days, 31 days. That's elementary school if you're doing it like that, right? If you enter the time as calendar date, Excel is automatically going to take care of that. So now, next problem. So you have $35,000 promissory note at 11% interest rate, and this row 59, first row, right, is related to this. Second row is related to this timeline, right? And this time, yeah, that timeline. So time in years, we know it's this minus uppercase T, terminal time minus T0, close parenthesis, divided by 365. There you go. And what's going to be the future value? The future value is going to be E times R times 1 plus, open parenthesis, and 1 plus R times T, right? And you can also drag it down. And let me drag both. Okay. Second problem, you can take care of the second problem at the same time. Now this is, then think about it. If you are holding on to this promissory note until maturity, right, April through September, right, then you will get this. The second problem, you will get this, but you can't hold on to it anymore. Why? On June 8th, your company ran into a cash flow shortage problem, so you cannot hold on to it anymore. So you took it to the bank or to a factor, right? And the factor used 9%, right? So the discounting period, this called discounting period, is basically what? It will be the maturity, terminal time minus T1. That's when, and then using exact interest here. Now it's got too many digits. You don't have to leave it like that. You can do, let's just use, like decrease decimal, just about this, right? And then what is the bank discount? What is the effective interest rate and so on? So we'll find the so in this case, this will be the primary solution. We'll find so the proceeds will be maturity value. This is the maturity value, right? FV is the maturity value, isn't it, right? Times 1 minus discount rate times T, right? There you go. And then the bank discount is the difference between the two, right? There you go. And effective interest rate is what? This divided by, right? B divided by D times T. No, that's not T, I'm sorry. This is the T, right? There you go. Okay, 9.23. So compared to a discount rate, effective rate is greater, right? So if you highlight all those cells and drag it down, second problem is also taken care of. Now, last not the least, neat housekeeping, right? Very neat housekeeping. So click button. There you go. Now here's the thing. Some people may ask, is there any verbiage, any words? Yeah, here's the words. So this data is given. From the data, I've been telling you, from the data, you should be able to construct the narrative, correct narrative. This is what this is. This, right? We gave you a length of note, 160 days. This is slightly. How do I know 160 days from April 8th is this? Of course, I did. I found, right? G5, this plus 160, and then you'll get that. Okay, and then so this is the the only thing different is the there's interest rate bank discount. So this is one problem with 4 parts, right? That's why I answered it exactly like that. Maturity value, right? I didn't have to put interest separately because this together with this interest is obvious. But if I didn't want to add another column for interest, but discount rate and discount period, I found discount period. But that was actually B. This is B, not this. And then bank discount, that was C. D is proceeds. Oh, but I tweaked it a little. I made D the part D effective interest rate. All right, here's one more thing. One last thing. Usually the banks. This is usually, think about it. This might be the reality in why will the banks use lower discount rate than the interest rate on the note? Logically, now I'll leave this as food for thought, and I would want you to post in the discussion board, right? Why the banks wouldn't use a lower discount rate than the right? Because if a bank the bank employee, the person responsible for discounting the notes, applied lower discount rate than the interest rate, then most likely this will work to his own detriment, and for his career, this may not be a good thing because. So that wraps up everything about the simple discount. So I will see you guys in the new video with another topic. Okay. So the next topic.
All right. So that wraps up everything about the factoring or simple discount, right? Which was extra session needed to understand what promissory note is and how it works, and how accounts receivable works, right? In other words, they are not generally they are not held to maturity, right? Because if your company is doing well, if your company has a lot of cash flow, you can hold it to maturity. You can carry it to maturity. However, most of the small businesses, right? Most of the small businesses are very tight with cash flow, so they cannot hold it to terms. Right? They cannot hold it to maturity. They cannot. So they will generally factor it. They will, and just cash out in advance. But obviously, you cannot get the full face value, right, or full maturity value, because you are, by discounting, you are transferring the risk to the bank or the factor, right? You get discounted amount. That's why it's called discounting. Using simple interest rate, using simple interest rate principle. And why is it called factoring? I explained it in the video, right? There was in most of the European countries, it's very common term to call invoice facture. In French, Italian fattore, Spanish factura, which became, which got anglicized when it came into English language. It got anglicized as factor, right? and so on. And so that wraps up everything. And we are a little. Next topic will be topic three. Uh, but it's 6:58, and since next topic is a new topic, we're gonna take a break here, right? We're gonna take a 10-minute break here and reconvene at 7:10ish, right? 7:10, around 7:10. Okay, so we're gonna move on to time value of money. All right. All right. So let's take a 10-minute. Okay. Let's take a 10-minute. Let's take a 10-minute. All right, we're back. We're back. Um, so, um, time value of money is the basis and foundation for all financial mathematics that are related to finance. And remember the geometric average, right? How we calculate geometric average. And there is, geometric average is required because there is compounding. So actually, this topic is all about how that compounding formula came about and how that geometric average formula came about, right? All right, so let's take a listen.
Time value of money and compounding. Now, we already understand a lot about compounding because we started out with the example in compounding. And time value is, you might think this is a new concept, but actually this is not a new concept because we all understand there is value associated with time. In other words, compounding is a process that clearly indicates that there's a trade-off, right, between today's $10,000 and the future value of today's $10,000. In other words, if you do not spend $10,000 today, that means you're foregoing the consumption that the $10,000 can provide for you, right? So then, if you are, instead of spending $10,000 today, and when you spend, basically a consumption is contributing to the enhancement of your utility, which means your, it's also called, felicity or satisfaction, right? But you could use $10,000 on on a holiday cruise or vacation today, or you can save it for tomorrow. And if you are saving it, right, then you are trading it off. You're trading today's consumption off with bigger return in the future. Obviously, you won't trade off today's consumption of $10,000 with tomorrow's consumption of $10,000, right? I mean, if you're putting it off for 1 year, that means you're putting it into something like some savings instrument like CDs for 1 year. And obviously, you're not going to do this for free, right? I mean, you are sacrificing today's, gratification. I mean, we are putting off instant gratification for a bigger gratification 1 year from now. Meaning, if the interest rate is 10%, 1 year from now, it's going to be $11,000, right? That's the future value. You're trading off, and as long as there is no inflation, right, between now and 1 year later, then 1 year later you will have 10% more purchasing power, right? So you will, just in a rough. I mean, the reality is not like this, but if you can consume 10% more, your utility or satisfaction will be 10% greater, right? It's a trade-off. Some people cannot wait for a bigger reward in the future. I mean, this is a famous, psychological experiment. You gave, one group. There are like 10 kids in a room, and you gave them like 5 marshmallows, and you told them, you told them that you will leave the room for 1 hour or 30 minutes, and when you come back, if the kids haven't eaten the marshmallows, then they will get twice as many, right? They will get the reward, right? And so the researcher left the room, and the 10 kids were left with 5 marshmallows, and some kids waited. They held out, right? But some kids couldn't. They ate up marshmallows. So what does that tell? People who are, there are people who are, who have propensity to, these are kids, they don't have any logical or, thinking. They just live by intuition, they would just, and some kids can visualize, some kids can, understand that they will have 10 marshmallows if they just hold it out for, 30 minutes. Some kids cannot even visualize that future. They live for instant gratification, and that's also true. I mean, this experiment was with kids, but with adults, you see the same, still the same result. Some people cannot make sacrifice today for better tomorrow. That's why there is crime, first of all, because they cannot see themselves, I mean, if they commit a crime, just, a few weeks down the road, a few months down the road, they cannot see the consequences, right? They cannot make the connection. But anyway, so there is value associated with time, and we know that $11,000 in this example is the future value, right? And that $10,000 is the principal, and from if you're standing in the future 1 year from now and looking back at today's $10,000, that's called present value. And this this example is something we already did in topic 1. But let me, I already put it here. But let me just, reiterate it. Let me first stop sharing the PDF file, and then let me go to, let me switch to, we have principles in topic 1. Oops. Okay, cool. Now, let's say we have principal, which is 10K. And the interest rate, let's call this R. And then, which is 10%. And then time, let's say 5 years, right? And then our question is, what's it going to be in year 5? In other words, what's the future value in year 5? Oops. And then we know the process already, right? First of all, starting from year 1, at the end of year 1, we know there's going to be $11,000, right? But then the process, if I this is like all over again, showing you this process. $11,000 is the result of principal plus interest, isn't it right? And interest can be rewritten as, I'm not just first, principal. Interest is can be written as P times R times T, isn't that right? Interest is the result of principal times interest rate times time. In this case, T is 1, right? So you don't have to write it, because then, because it's 1, you don't have to write it. And then we know when there is a common factor, you need to factor out to make it, to simplify, to make the expression the simplest possible. So if I factor out common factor P, right, then you're left with P times 1 plus R, right? Now, and what is, and we know it is $11,000 already, because even without doing this, it's very easy. But if you want to plug in the numbers, like, this is going to be 10,000, right? This is 10K. This is 10K, and this says 0.1. In other words, 10%, right? 0.1. So the whole thing is 10K times 1.1, so it's going to be 11K, right? Now, then FV2 is following this process. FV2 is the future value at the end of year 2, right? So at the beginning of year 2, then what is sitting there? Is principal of 10K sitting there? No, we know already there will already be 11K sitting there, which is FV1, right? right? And then FV1 will earn interest for 1 year again. So 10% of 11K, so that's going to be 1.1K. But again, because interest is the result of multiplying FV1 by R for 1 year. So I'm not going to write, I'm not going to do multiply it by 1 again because it's 1, right? And then, so in year 2, you have already a future value 1 sitting there, and then which is 11K, and that future value 1 is earning 10% interest, right? So 10K times 11K times 10. Now you can factor out the common factor, which is FV1, and then you have 1 plus R in the parentheses. Okay. Now then, we can break down this FV1, because what is FV1? By definition, FV1 is this, P times 1 plus R. So I can rewrite FV1 by its own definition, which is P times 1 plus R, right? And then there is 1 plus R here. So another 1 plus R times 1 plus R. And then we know better than this. We don't write it like this. When we have 1 plus R times 1 plus R, so we already know we should write it like P times 1 plus R squared, right? Okay. Hence we find FV2 this way. What about FV3 then? We don't.
Okay, so I'm gonna skip this part because we have already done this enough in topic 1. So we know FVN is P times 1 plus R raised to N. So I'll skip, the overlapping part, right? I'll skip and go to the, right? This is the conclusion, right? That's basically, the very basic form of compounding, right? And it's called, compounding in single cash flow, right? Compounding with single cash flow. Let's continue from here, okay?
And we already know this. This is nothing new. Let me switch back to the PowerPoint, and let me go back to the PDF. Generalized, this is our, generalized formula. But this model is called a single cash flow model. Okay, I'm going to get to that definition later. But also you might wonder in the Word file where I drew the steps of derivation, the exponent was n. Why is it t here? Look, t is just generic notation for time. Okay, and time can be n. Time can be in many different units, but n is such as years, months, weeks, days, so this is just a generic notation just to represent the future values, the present value compounded in time periods, and n represents actual number, right? Number of periods. So our next question is, and this ties in together with our next question. So t can be simply replaced by n, and the reason we are talking about it at this point is because compounding doesn't have to be necessarily only annual, right? So far, our assumption was compounding happens once a year, right? Because of course, normally, if you put your money in the bank, you think you are earning interest annually, and that's normally the case. But it doesn't have to be just annual, right? In other words, compounding doesn't have to be annual. Compounding can be at a more frequent time interval. In other words, let me introduce additional variables, right? First of all, R, let me go back to the Word file, and let's go to So let's go to a. How do I? I'll have to. Um, okay. Oh. How do I? Okay. So I need to. This is ridiculous. This is crazy. So I think I'll have to. A couple of new variables. One. Oops. What's going on here? APR. You know what is APR? It's nothing new. It's annual percentage rate. In other words, APR is annual interest rate. We've been taking it for granted. I mean, we've used R as the annual rate, but the rate, as I said, compounding doesn't have to happen only once a year. It can happen. It can happen at any interval. For example, there's my. So I'm introducing a new symbol called M. And what is M? It's the compounding frequency per year. So compounding frequency means, if it is annual compounding, it's once a year, right? If it is twice a year, that's semi-annual compounding, meaning, every 6 months. And then there can be quarterly compounding. Quarterly compounding, literally, every quarter. So that's 4 times a year, right? And then if the compounding frequency is 12, what does that mean? Monthly compounding, right? Every month. And then 365, what does that mean? Compounding happens daily. So then, how does this work? Look, if, let's say APR is 6%, annually 6%, right? But then if compounding is once a year, of course, the APR is exactly the R, the rate, right? But if compounding is twice a year, what does that mean? Every 6 months, you earn 3%, right? Because so first 6 months you earn 3%, and in the second half of the year you get another 3%, but that gets compounded. In other words, what you have already earned, 3% that you have already earned becomes part of the principal in the second 6 months, in the second half of the year, and then it earns 3% again. So in that case, if it is 2, then R is 3%. We know it is APR divided by M. Okay, so the name, so M is the compounding frequency, then R is called periodic rate. Periodic rate. Okay. Now, what happens? So if R is 12, right? I mean, if M is 12, meaning it's monthly compounding, then what's going to be R? Of course, then 6% over, right? APR over M, 6% over divided by 12. So it's going to be 0.5%, right? 0.5, right? Or 0.5, 0.5, right? So then think about it. How many compoundings? I mean, if compounding frequency is 12, what does it mean? How many compoundings happen per year? 12 compoundings. And if M is 4, what does that mean? That's quarterly compounding, right? Then R would be, again, 6% divided by 12. That's going to be 1.5%. Now, then suppose we have our time is 5 years. If compounding is M is 4, if M is 4, right? So how many compoundings happen over 5 years? How many compoundings happen over 5 years? Annually 4 compoundings, so over 5 years, right? 4 times 5, right? In other words, m times t, right? M times t, right? So in our example, it's going to be 20 compoundings, right? And this is called n. Okay, so n is the actual number of compounding. N, right? T is just generic notation for time and usually years, but n is the actual number of compounding, right? So if we rewrite the same problem, right? So principle, let's try that. Future value n is p times 1 plus APR over m raised to t times m. But then this is, once again, back to p times 1 plus r raised to n. But this time, r and n are different. In other words, previously, r and n, r was, if p is 10K, our APR was 6%, APR, 6%, and T was 5 years. Okay. But then when compounding frequency was 1, in other words, annual, then you would write future value will be 10K times 1.06, right? 6% is 0.06 raised to 5, right? If m is 1. But then if m is 12, then if m is 4, will be 10K times 1.015, right? 1.5% is, right? And raised to 20, right? If m is 4, compounding frequency is 4. In other words, if compounding is quarterly, right? So now this is, how we can tweak the the basic compounding formula, right? To adapt to different compounding frequencies. All right, so that's it for this segment of the video, and I will see you in the next video.
All righty. So we're moving on to the single cash flow model, right? Future value, part 2.
Money. This is Dr. Jeff Holm, and we are now looking at an Excel file. And once again, just for your information, all of these files that we are using for the class are located in the each respective topics folder.
Okay, so this is that Excel file, right? This is
right. The first in the course materials folder, most likely the first 2 files on the top, 2 or 3 files on the top in each folder. If you go into each topic, the first couple of files on top, those are the files that we use for the class. Okay, so you can download this file, which is titled time value, right? And it's an Excel file, and there's also a PDF file of the slides that I'm using. So don't just watch the video, and that's not the end of it. You should be exactly emulate what I'm doing, what I'm demonstrating in the video. Okay, you understand? And sometimes you might find solution cells already filled in. But if that's the case, then you can just simply clear it out, delete those cells, and then just follow and follow my demonstration. Okay. I mean, if you may not be able to do it while watching simultaneously, right? But then after watching the video, try it on your own, or you can replay the video and put it to a pause while you, right? It's just self-explanatory, right? If you want to follow my demonstration, you'll just need to pause the video and just catch up, right? All right. So now this is the setup of the example we used the last class, in the last video. First of all, let's take a look at the labels, right? P, of course, stands for principal. APR, of course, annual interest rate. Time in years. Now, M is the compounding frequency, right? Of course, that's future value. So our last example was like this. Principal was 1,000, 6% APR, 5 years, and compounding is annual. And in that case, you simply the future value is equal to future value equals, right? This is exactly what it is. Logically, this is the cell where future value must go in, right? But then how do you find future value? Well, if you exactly build the formula into this cell. So literally, future value is equal to, then principal, this is the principal, right? You just click it in, right? You think, some people are typing in A3. No, don't do that. That is, I didn't type it in, right? What did I do? I clicked it in. Using the mouse, I clicked it in, okay? Because if I manually type it in, you would see A would appear first, and 3 will appear after that. But that's not what happened. A3 appeared simultaneously, right? It wasn't 2 strokes, it was just 1 stroke. So what does that mean? I didn't type it in, right? So I just clicked it in, and then because I'm doing exactly reproducing the formula, right? Because that's the principal, right? And then times, open parenthesis, 1 plus R, right, raised to APR, right? That we talked about this at the beginning of the semester, right? This is called caret, right? Which is a universal machine language for raising something to power, right? So raised to 5, okay? And hit enter, right? And there you go. So actually, the benefit of, you might think, can I do it just, on paper, with pencil? Yes, you can do it that way. But the benefit of using Excel is if you have multiple problems of the same pattern, right? If you have multiple problems of same pattern, you can do, for example, if I have the problems like this, over and over, right? A dozen of them. I don't have to, if you use, pencil and paper, then you'll have to do every problem, one by one, all over again. Each problem, the next problem, it's a new problem. You have to solve it all over again. It just takes a lot of time. It's not, in this day and age, you don't, well, you need to be efficient, right? Time, the old adage, time is money, is not, it's not 21st century concept. It is a very, very, very old concept, right? Whatever saves time. But it's not like, but I'm gonna get to that later. But you may have noticed that once I found this, then this cell automatically populated. How? Well, it's simple. I just made it equal to this, right? So once I got this, then automatically this will be filled in. Logically, think about it. If this is made to be equal to this, then it's going to automatically reflect whatever is here. Now, so that wasn't that bad. I mean, that wasn't, that it's very basic, compounding formula. It's not that difficult. Now, What about if compounding frequency is 4, in other words, quarterly? Then we'll have to make adjustment, right? We've done, you've seen this in the previous video. So all you need to do is simply, once again, principal times 1 plus, right, APR, and you divide it by compounding frequency, right? And then raise it to T times N. Okay, and then make sure you have parentheses, right, around the T times N, because without parentheses, what's going to happen? If you don't put parentheses, what will happen is that if there is no parentheses, what's going to happen is the formula is just linear, written linearly. The formula is written linearly, so Excel will execute it linearly. So this will be done first, right? And of course, first of all, whatever is in the parentheses will be done first, right? Of course, this will be done first, right? Because it's always a PEMDAS, right? Division will be done before addition, right? And then it will be multiplied, right? And then what's going to happen? It will be raised to power. It will be raised to power, and then it will be multiplied by D2. So then that's not right. That's not C2 times D2. In other words, T times M is the N that this term should be raised to, right? So you must make sure that you put it in parentheses. And once you do that, what's going to happen? Yes, this is the future value when compounding frequency is quarterly. Now, and what do you notice? Oh, it's the same, basically same input data, right? Same principle, same APR, same 5 years, but different results. Of course, you get greater future value, right, with higher compounding frequency, right? It's not that much greater, but at least, between this and this, which one would you prefer? Of course, nobody will prefer this. Nobody in their right mind will prefer this, right? The bigger the future value, the better it is, right? And the reason, so this gives you a new realization. Although all the input data are the same, right? The higher the compounding frequency, right? The higher the future value, right? Because more compounding, right? More frequent compounding results in greater final result. Okay, and also, but that the difference cannot be, the difference will be, of course, it's difference is, discernible. In other words, you can tell the difference easily, but it won't be that, it won't be outrageously different. For example, you can also tell whether you have to use your own judgment, critical thinking, right? You cannot just leave it to the formula, right? Because if you made a mistake like this, right, previously, if you make a mistake like this, how do you know you got it wrong? Look, this is your critical thinking. While the compounding frequency may be different, but that difference cannot result in this much, outrageous difference, right? This is exorbitantly different, right? You're starting from 10,000, same 10,000 principle, same APR, same 5 years. Just, difference in compounding frequency cannot result in this much difference, right? And anybody who has, who can think, right? Anybody who has, that's critical thinking, right? But that's, in the old days, they just called it thinking. People who could think will question this, right? You won't just, walk by, right? But once again, all these things, when you're young, your brain isn't, at this level. I mean, you just, I just did whatever, the professor taught me, so it must be right. But, when you didn't do it right? Because, if you missed the parenthesis here, then you didn't do it right. But how can you check? You have to have that, you'll have to have that mindset, right? You cannot just, walk away, You have to make sure, you have to check whether you got it right or wrong. And before looking into the formula, you can already tell something's not right. If there's such an excessive difference, such an outrageously huge difference, then something's wrong, right? And this is critical thinking. And when you're young, you are more likely to just to walk away, right? It's Excel, so it must have, it's what Excel did, so it must be right. No, is what you did. You didn't, right? Excel only, executes the Excel only executes the command you gave it, right? And if you give it the wrong command, it will just execute the wrong command, right? So it's finally, I mean, it falls upon you, right, to make sure Excel carries out the right command. Now, another thing is here, I told you before, you know how to copy and paste. Now, if you did this first, you can simply copy and paste it down, right? But then you might wonder, well, why do we need to do that? I mean, is there anything different? Isn't that the same thing? Of course, on the surface, it's the same number, right? Of course, how can it be different? But in the structure, look into the deep structure. I wouldn't. This is the term I borrowed from Noam Chomsky from his linguistics. Deep structure. In other words, if you look into the formula, right, the formula has changed. I mean, it's the same formula, but previously I used this, right? But this time I'm using this because I copied and pasted this formula. But then what is the difference? There's no difference. I mean, in this case, but the only thing is that I divided it by m and multiplied it by m here. But then, m is 1, so it doesn't make any difference, right? M is 1, right? And doesn't make any difference, right? Because 1 doesn't change anything. But then why do we do it this way? No, first, we have uniform format, right? It's consistent, uniform structure is very important because it can be replicated over and over and over. For example, let me insert a couple of more columns and let me okay, not dollars. Okay, and then let's say I have a couple of more problems like this, and each time, right, compounding frequency is different. What else can it be? Quarterly, monthly, daily. What else? 2 semi-annually, right? So I have different scenarios, right? I mean, with the same input data, the scenarios are each time the compounding frequency is different. And how do you? You don't have to solve everything one by one. All you need to do is simply copy and paste the formula, right? And then automatically, it's the same formula, but it adapts to new compounding frequencies automatically, right? So think about it. When you are dealing with massive problems, massive number of problems, right? It really it makes it a lot easier, right? And it's not like you are copying somebody else's work. You have done your work already. You're just replicating your own work. You're just copying your own work. So there is nothing. What did I do? There's nothing. You have proven that you can do this, right? So you don't need to prove it again, because you have already proven it. So you don't need to do it all over again. You can just simply copy and paste it, and then you can handle massive problems, right? And let's sort this. Let me sort this, right? Because this is in oh, no. Why is it doing this? Why is it? Let me sort this. Okay, let me do this. Where was that? Filter. Okay, and then sort by oh, I see. The reason this is happening is because if I sort it, then because of this equal signs, so let me. So let's see if I do it like this. Well, so then if you sort it in ascending order, right, then you can see in just one single view, right, the higher the compounding frequency, right, the greater the future value, right? Now, let's take a look at row 9, right? And in the original file, right, I had only 2 rows and I inserted more rows. So you may try this later. It's the same setup, 5 years, right? And just, annual compounding. But what I have 2 more columns. So, and these additional columns have labels like periodic R and N. So what does that mean? Well, that means I want to put R, periodic rate, and N there. So we already know what periodic rate is. It's 6% divided by 1, and 5 times 1. If it is annual, it's going to be like the same thing. There's no difference. But if it is, let's say quarterly, then you see the periodic rate automatically adjusts and automatically adjusts. And now all you need to do is simply apply this formula. So P times, future value is P times 1 plus R, not this one, because the periodic rate is already found. So all you need to do is simply then raise that to N and check it, right? Check if this is the same thing as this. Yes, of course, right? This is when the compounding is quarterly. So what's the difference here? There isn't. The only difference is that here I didn't make adjustment, right? I mean, in this case, I made adjustment to APR and T, right? In other words, eventually APR divided by M is what? That's R, periodic rate, and T times M is what? That's N. But I made that adjustment inside the formula, right? But here I made that adjustment outside of the formula, right? I made that adjustment outside the formula. Then what's the benefit of that? The formula can be simpler, right? Now there's another benefit that comes with the simplicity. Now these are still very simple formulas, but if the formulas get more and more complicated, if you make any mistake in the formula, then it's going to be difficult, or it's going to take more time to locate and identify the source of the error. In other words, it will take more time to fix it. But if the formula is simple or simpler, right, it's easy to identify the source of the error, right? And then you can fix it easily, right? And besides, think about it. If the error was made here, right? Let's say instead of doing like this, you should have divided by that, but you click this accidentally. Then it comes to this, and this is already just by simple mentally you can check. Oh, what's wrong? I mean, is 6% divided by 4? Is that 1.2%? Can it be? And something using your critical thinking, you can. So where did I go wrong? You look into it. It's easier to find rather than finding it from here, right? Rather than finding it, if it was like here, if the problem was here, right? It would be more difficult to find the source of the problem. But if it is like this, it would be easy to find. Oh, right, I made a mistake here. So then you can fix it easily. And once you fix it, then right, it's going to be automatically taken care of. All right, so that's it for this video, this segment of the video. I will see you in the next video. All right, thank you for watching.
All right, so any questions so far? Any questions? Any questions? I've expected some questions, when it came to this topic because it's mathematical topic. No one? Are you guys there? Anybody there?
I'm here.
Okay.
Just don't have any
Lacey,
questions.
you don't have any questions. Okay. Good, good, good. Oh, okay. So, all right. So you guys have no problem with this topic. That's a good thing. Now, let me just yeah, hi Coral. So you all right. So we have about 20 minutes left. I guess we can I can go one more, but no, we don't have because the next one will be at least 30 minutes, 30 minutes, uh, 30 minutes, 30 minutes. So now let me briefly explain instead of going any further. Let me briefly explain uh, how you're being graded. I mean your final grade, how it is calculated. So I would like to just bring your attention to the last year. I mean, yeah, last year. I would. So this is summer 2022. A file has been downloaded. So let me open that. So, because you've taken 2 tests so far, but which are relatively um, less in percentage, less in weight, right? And they're not gonna they're not gonna factor in a lot into. So here's what happened. Basically, you are all graded based on quiz 1, midterm, quiz 2, final, and attendance. Okay, and quiz 1 is 20%, quiz 2 is also 20%, midterm 25, final 25%, attendance 26%. So if you take a look at this weighted average, right? 0.2, B2.
Professor,
B2.
sorry to interrupt. Professor, quick question. We've only had 2 quizzes so far, correct?
That's actually not quiz 1. I mean, this is not you. This is from last year. Summer
No, I know.
last
I'm
year.
saying so far we've only had 2 quizzes, right?
Yeah. You've had just 2 quizzes, right?
Okay, perfect.
Which are not even shown here, but I'm just showing you the overall structure of your grade calculation. So
Okay, perfect.
D2,
Thank you.
D2 are 20%, right?
So how many
C,
quizzes do we have for the summer?
hold on. Hold on, I'll get to that. C2 and E2 have 25% weight. F2 is the attendance that has 10% weight. Now, so the result is the weighted average, right? And the weighted average are sorted, stacked, sorted in descending order, and the mean of that weighted average was almost 70. That's relatively good side. I mean, high. Over the last 20 years, right? In summer, right? Summer, and even in regular semesters, mean of the weighted average ranged between 60 and 70, roughly. So if the mean was like almost 70, that was good. And I use standard deviation and mean for distribution of grades. So the look at this. I mean, this can be a little. This can be adjusted a little. As you can see, um, the cutoff line for A is the mean plus one standard deviation. So that's one standard deviation above mean. And one standard deviation above mean was this. If the mean is like 60, around 60, I use 1.25 standard deviations. This is statistically, this makes sense very statistically. This makes perfect sense statistically. But, I'm not getting to statistics just yet. And 0.75 standard deviation for A minus, cutoff for A minus, and so on. It goes. So if you are just about the mean, you will get, see, my general rule is, if you are just about the mean, that gets median grade, and the median grade is B minus, right? Because there are like 9 grades in our one. But however, when the mean is, this is almost the 70. As I said, I make adjustment. If the mean is about 60, yeah, usually, the range for B minus is mean plus 0.2, mean minus 0.25 standard deviation, and which is the lower bound, upper bound, 0.25 standard deviation above mean, and so on. And so F is really statistically really difficult to get. Why? To get F, you have to be at below 1.75 standard deviation below mean, which is statistically a very low probability, actually. 1.75 would be like bottom 10%. If there's a 30 people in the class, bottom 10% is just one person. If there are 20 people in the bottom 10, that would be like usually it's not even bottom 10%. It would be like bottom 5%. Bottom 5%, sometimes, with a very small class size, you cannot even be a whole person to fall into really bottom 5%. It's a fraction of a person. How can you be a fraction of a person? I mean, that's probability. I mean, the probability of falling into that range, to fit that probability, you have to be a fraction of a person, a partial person. That cannot be. So anyway, so these two quizzes, how do they work? Actually, I use average of these two tests, and then I use it to bump up. For example, if you are at marginally B minus, if you're marginally B minus, that means you just didn't make this. Let's say to be in B, you have to be this. But let's say this is marginally below B. So for every grade level where you are marginally below the upper grade level, then I in this case that wasn't necessarily done, but I replaced. See, in this case that wasn't done, but I normally use the average of ROI tests to replace the lowest score in these exams, right? So that will bump it up a little. It won't bump it up a lot. It will bump it up enough, just enough to marginally push it to the next grade level. But in last year, I think that wasn't necessarily needed because so normally every semester, it doesn't matter whether it's summer or regular semesters or winter immersion. I use average of ROI to bump up. For example, this person, right? Obviously, this is the lowest, right? Of course, this person has to be like marginally below A minus. But that wasn't the case here. I mean, this person had very low midterm. I probably and this person. Okay. See, this person had a better. The average of ROI tests were better, and this person can. I don't know if I applied that last year, but if I didn't, there must be a good reason. But usually I do that. So I didn't do that last year, but I normally do that. Oops. So it's important. The point is, it's important that you do every test, that you give your best shot to every test, and it won't betray. I mean, if you did, you might say, "Oh, these two don't even count. I mean, that much," but it might come in handy, and it might come in for your rescue, right? For any regular exams that you didn't do well, right? So keep that in mind. And so the distribution, this looks quite like normal, roughly, right? It's not really, I wouldn't say, because there were spike here. Normally, so it looks like a normal distribution curve with the mean somewhere here, right? And that's okay. And that is 73, 72, 72. Yeah, a lot of them, right? A lot of them were placed in B to B plus category, right? See look at the distribution here, right? Um, and look at the cumulative. I mean, A in the A range. I mean, two people were in A range. That's like 13% of the class got A. Nobody got A minus, but 6% got B plus. But cumulatively, 19% got B plus and above, and then 19% B, 19% B minus. So totally, I mean, overall, about 70% of the class got C plus or above, right? Actually, those who fell under C, very small fraction, right? 6%, 6%. No D's, there was 6% F. And if you look at F, this person didn't do. Obviously, if you don't do 20, this is 20%, this is 25%, that's 45% of your grade. And by missing 45% of your grade, obviously you can't expect to pass. And those who, these people probably dropped out later, so obviously no data. If there's no data, obviously no. And after calculating this, I checked the with Cuniverse to check if people have dropped out. Some people have. If these people got dropped out, I give WU or W or WD depending on. I mean, if these people actually took the process of withdrawing from the class, it will automatically W will be automatically appearing in their Cuniverse. If they haven't done it, they will still be on the roster. Then I will have to manually enter WU, unofficial withdrawal, right? And etc. But because this is done by algorithm, right? I do it by algorithm. It's automatically, finding its own grade. Okay, so so that's how. Oh, what time is it? Oh, yeah, it's almost time. So that's how it is being done, right? So you just give it the best shot, and if you did something, you feel that you didn't do it something well, then there's always a something to fall back on, right? Uh, all right. Anyway, so any questions? Someone had a question, I believe, right? Someone had a question. Any questions? No? Okay, if there are no questions, then I think it's it's a good time to call it a day. So have a great evening, everyone, and I will see you guys back here tomorrow at 6 p.m. Okay? All right? All right, then, have a great night. Take care, and see you tomorrow.
Good night. See you tomorrow.
All right, good night. Take care. Take care. Rostam, yeah, you had a question, Rostam?
I have a question, Professor.
Yeah. Go ahead.
I looked
Thank
through
you.
Blackboard, and for one of the assignments, I'm looking at it right now. It was a practice test due
Oh,
at
okay. Oh, hold on.
11:59.
There's some echo, and can you speak up a little?
Could you hear me?
Yeah. Now I can hear you better.
Okay. There was a practice exam that was due last night at 11:59 p.m. And I just wanted to know for sure if this was going to be graded.
Yeah, it's graded. Everything is graded. Yeah, this is still it's still open. If you didn't do it, the announcement went out, right? You should have been notified, right? You were notified because the announcement went out.
Yes.
The first ROI concept check.
I had a few, not the first one. It was the second one,
Yeah.
which was
This went out. This notice went out.
I
Yeah,
saw it, but I saw the announcement, but I reserved on doing it because towards the end of the assignment it said that this is a practice and thus graded only for self-assessment purposes only. So I had thought that this would simply just be.
But yeah, that's fine. I mean, you don't if you nothing wrong, not because as I said, it's not directly graded into, it's not factored into your term grade. Yeah. However, as I showed you, the average of these first two tests will kick in. I mean, if you do, let's say, if you don't do well in the midterm, and if the average of these two is better than the midterm, it will replace the midterm to boost your weighted average calculation. So it will come in handy, right?
But will it lower your score? Because
if it is lower, then if it is lower, then it won't be used.
I see, because I did the first ROI exam. I did well on it, and I just didn't do this one yet because I just simply assumed that it would be for practice. But now I'm looking at it, and it does look like it's open still. but I
Yeah, yeah.
believe this is already past the
No.
date.
Wait. Because the due date is passed, I will have to add you. I will have to extend it for you. Otherwise, I mean, it's open for review. For those who have already taken this, it's still open so that they can review. However, if you haven't done it, you cannot do it without extension. So I'm gonna extend it. If you want to do it, you want to do it tonight?
I can try and get it done by tonight,
Yeah,
if
yeah, yeah.
not early
I mean,
tomorrow morning. I don't
uh,
know. I'm not exactly
I,
sure how convenient it would be for you. If
I
it's
will, I
inconvenient,
will.
I could get it done today.
Mhm. I mean, think of it. Look, once again, as I said, it's a practice. So if you do it, it's better. I mean,
Yes, of
you
course.
certainly learn something from the practice,
Yes.
and it's not. It doesn't directly factor into a weighted average calculation, but it can help,
Yeah,
right?
that's for
In
sure.
case you do very poorly on
So
something.
would you recommend I finish it today?
Yeah, yeah, I would. I will extend it to 11:59 p.m.
Okay.
tonight.
I can try and get it done by tonight then. Yes.
Or, I mean, if you feel more comfortable, I can extend it till 9 a.m. tomorrow. 9 a.m. How does
Yeah,
that
yeah.
sound?
Whatever works for you, I think would be fine. I think
Uh,
either 11:59 or 9 a.m.
okay,
They're basically the
yeah,
same for me.
11:59. 11:59 then. I will extend it. Okay?
Okay,
So
I'll get it done.
check back in like, 10, 20 minutes. It will take some, time for me to reset it.
I
Okay?
understand. Thank you.
All right. All
See you
right, you're
tomorrow.
welcome. Okie doke. Okie
Have a
doke.
good night.
All right. Good night. So